Lovely bones, won't you take me home? 'Cause I'm lonely. And hold me close, you're my only ghost. Come on, haunt me, 'cause I'm lonely. And I've been gone too many days, and it starts to feel the same every morning. And I don't recognize this place. Is it me or have I changed? They ignore me, and that makes me lonely. And when I hear my name.
So this is my experimental setup. I have 2 cameras, 2 tents, and this one I'll be looking at response to bird mounts. So here we have a little messed up hummingbird attached to this branch that I put. So I'm gonna throw the tree crops in here and then video record them and see if they might make any attacks on this poor little bird, because that's something that we have seen in a previous experiment. But with my own, I'm looking into it further. And another aspect I'm looking at is if they would attack nests with eggs. But yeah, that is my setup. Pilot night 1, we'll see. Hopefully everything goes smoothly.
There she goes, like I've never been alone, like I've had it all along. And every time I go away, I hate that it's a day that I never see your face. I'm lost in outer space, and when I'm looking down below, there she goes. I've been floating around every city and town, cars and bars. I can't figure out why these crowded rooms feel empty without you. Every name, every face, so they all start to fade away into the back of my mind as I lie awake thinking about running back to you. So I pack my bags, I'm taking off, I'm coming home. There she goes, like I've never been alone, like I've had it all along. And every time I go away, I hate that it's a day that I never see your face. I'm lost in outer space, and when I'm looking down below, oh, there she goes.
Touch early. Our next speaker is Mary Heather Jinko, and I'll turn it over to you.
Awesome. Buenos and happy day, everyone. My name is Heather. I'm a Ramp-Up Fellow with the Global Sustainability Scholars Program and the Smithsonian Tropical Research Institute over in Panama. And today I'm going to be talking about a bat that eats birds. So a little shift from our morning session talking about prey, we're going to be talking about predators. Now, we're all familiar with how communication works. One animal transmits information to another, usually that within the same species, but the reception of that information isn't limited only to the intended receiver. And sometimes other animals can be sneaky and take advantage of that information exchange, and these are what we would call eavesdroppers. And there are many different eavesdropping systems that can be found all around the world, ranging from small antelopes who listen in on the alarm call of these birds as an indication of when they would need to flee. And we also have bush crickets. Males listen in on females responding to other males in order to intercept that interaction. And of course, surprise, surprise, these systems are found in the bat world as well. Now, one of the first things that interested me when I was learning about bats in Panama was just the diversity of species and diets that can be found in one single family. This right here, Phylosmids, within this family alone, There are frugivores, insectivores, carnivores, basically all of the vores that you can imagine. Yeah, and going back to what I've just introduced, a couple of these bats are eavesdroppers as well. These leaf-nosed bats have expanded in so many new niches and habitats because of this ability to specialize in so many food sources, and one bat in particular is what I would like to introduce to you today, which is Trichopsorosis. So the frog-eating bat, or the fringed-lip bat, whose distribution was previously thought to be up and throughout Central America down to South America, but as of a paper released just yesterday, they're thought to have 3 subspecies, but these are actually 3 separate, distinct species. And just to clarify, the species that I will be talking about today is Cirrhosis. So yeah, these bats are what we would call passive gleaners. So you may notice that they have these really large ears. They're super adorable. And instead of taking their food off, like from the air, like most insectivorous bats, they take it off of vegetation, the forest floor, or other surfaces. So, and it's hard to use echolocation in these cluttered environments in order to find their prey. So what they really do is they eavesdrop on the sounds produced by their prey, like moving through the environment or communicating with like their other species. So the frog-eating bat obviously loves frogs. They're loud, they're constantly communicating at night, and they're relatively easy to catch compared to other prey species. This here is an example of one of their favorite prey items, the tundra frog, and this is what they sound like. So cute, so loud. But these bats don't always eat frogs, and their diet can include arthropods, reptiles, and sometimes even other bat species, some of like the really small ones. And extensive research has been conducted on Trichops responses to various acoustic cues and for what these prey makes. However, these have mostly been done with frog species only, and for the most part, there is limited information on the diversity of wild Trichops. But with the help of DNA metabar cloning techniques, on fecal samples that were previously collected in Panama, we now know to a greater extent what they feed on down to the species level. And this study found the expected anurine species, but also found diurnal prey like lizards, and one fecal sample in particular found hummingbird DNA, specifically the white-necked jackfin. And what the study by Jones et al. Did was look at the behavioral response of this aspect with the hummingbird, only with 4 individuals, so it's like a very brief side project. And of those 4, none responded to the acoustic cues of like hummingbird vocalizations, but however, one did attack a bird mount. Just a little warning for all of our bird lovers here. Yeah, and one of them displayed a very aggressive response to that. And here in Panama, this is a novel behavior. However, in Brazil, trichops have been identified feeding on birds, and this is still Trichopsorosis, both through direct observation and identifying food scraps or other cold remains that are found at the bottom of their feeding roosts. And birds were actually the main prey item of these bats during that study period, even though there are also frogs available in that same location. So it would range from pippa birds to manakins and even some small bat species like Corolia and Myotis. And in addition, a separate study found phyllosomid bats preying on nests. And although trichops weren't identified in the study, it just goes to show that this behavior is present within that family of bats, and that bats could possibly play a larger predatory role for birds. Now, let's rewind a bit. I mentioned before that these bats are gleaners. Their whole thing is that they listen for their prey's calls in order to find them. However, birds are diurnal. They're sleeping during the night, and they likely aren't moving or making a sound. And there isn't any activity overlap between these species. But the bats obviously have some sort of foraging strategy in order to find these birds, as the behavior occurs elsewhere and has recently been documented in Panama. So my questions are, how common is this behavior? As fecal samples only display the dietary information of these bats from their last meal, and analyzing them can't distinguish between an adult bird versus an egg, we can predict that bird eating and nest predation is an uncommon behavior that just hasn't been sampled for yet. And along that note, would size and type of bird matter? We can predict that limitations of body size and morphology would lead for these bats to prefer to eat smaller bird species, and that easily accessible nests are what mostly would be predated on. Now, all of this work is being conducted in Gamboa, Panama with the Smithsonian Tropical Research Institute, and what I'll be sharing today is just preliminary results as a result of the past 4 months of working on this project. So what we first set out to do was create taxidermy bird mounts. We know that the Jacobin hummingbird was found in the diet of Trichopterosis in Panama, and that mannequins were eaten in Brazil. So with the help of the Smithsonian Bird Collection, we selected the following species with a distinct size and weight difference. So we have the striped-throat hermit, the band-tailed barbthroat, and the gold-collared mannequin. And then we set out to capture adult bats. And this was done either at night through mist netting and setting up a speaker at the bottom of the mist net in order to draw trade-offs in, or by capturing these bats during the day at bunkers, tunnels, or artificial roofs, like where we basically know that these bats are. And the first night of capture was their habituation period in the flight cage. The following night is when I would test these bats. I put them in a tent, and the bird species were presented in natural sleeping positions. And trials began at 7 p.m., which is their usual starting period for foraging, and would last for 3 hours. These are also recorded and then scored for interactions after. And what I also included was a control object, just to determine whether interactions were due to the bat seeing the birds as a prey item rather than just a novel item in the flight cage. The nest buffet is also set up similarly with a control object in various nests with quail eggs. Trials would last for 3 hours and recorded and scored afterwards. And as I moved between testing different individuals, I would also randomize the places of all of these items, just to control for how they're presented. And furthermore, I also wanted to add a field component rather than just testing these bats within a captive setting. So trail cameras were installed in known foraging locations with birds, mounts, and nests, just to detail the response in a natural setting. And so far, we've tested 6 bats, which is a very small sample size, but I'm still continuing this project later. But of these 6, we've already had 2 respond to the bird buffet experimentation. There is no bat interaction with the control objects, meaning that they do see these as prey items. But there's also no predatory events seen in the wild or in the nest buffet. But what I would like to share is one of these interactions with the smallest bird mount, and this is Zeke. He was very excited about that because this interaction actually lasted for 3.5 minutes, and this is just a small portion of it. Like, you would think that they would realize that it's not alive, but he just kept going. Now, moving forward, we're going to continue to test as much bats as we can in Panama. And these bats are only a small fraction of the trichops that we can find in Gamboa, and we'd like to provide, obviously, a more accurate representation of the population. And of course, with any study, you end up with more questions. I'm really only looking at how common this behavior is, but how exactly do they find these prey? What cues are they attending to? Is it individualistic preferences? Is it cultural? So many questions. And as of the paper released yesterday detailing that Trichops is actually 3 distinct species, is there a difference in species between them? So I think it would be cool to compare between Panama and Brazil bats and see what's the difference between them. And although preliminary, this suggests that bird predation is an uncommon behavior, if not rare, in Panama. And as we continue to test as much Trichops as we can, the results could provide the first insight into the potential impact that an eavesdropping bat can have on diurnal birds. And with that, I would just say thank you to all the cool people that I work with, the Rampart Bat team, the bird team, and my catching team, and of course to the Smithsonian Bat Lab, who have many amazing mentors and supporters throughout the course of this project, the Global Sustainability Scholars Program, and the Smithsonian Tropical Research Institute. And with that, I'll open up to questions. questions.